We're on example 3 from section 3.1. It says find the limit as x approaches 1. This is example 3. Find limit as x approaches 1 for f of x, where f of x is defined to be 2x plus 3 over x plus 1. Okay, we saw in the previous example that that we found that we could just simply take the number that we were interested in and plug it into the function, because it doesn't matter how the function is defined right at this value right here at x equals 1. Well, if we notice on this function, there's really no problem with just simply plugging the number 1 in here. The only time that we would run into a problem is if we ended up with a 0 in the denominator. So you could use a table of values to evaluate this limit, but there's an easier way now. The easier way here, this is just another way to write the limit that we're after, is simply just to notice that there is no problem with simply plugging in the number 1. And again, the problem that you would potentially run into here, and that we will see, if you get a 0 in the denominator, then you're going to have to do something else to find the limit. We're not having that happen here. So if we simply plug in the number 1, that's going to give us our limit. So 2 plus 3 is 5. So we're going to have 5 over 2, and that's the limit. Not too bad, provided that this number here is in the domain of the function. That is, as long as we can just simply plug it in and not have to divide by 0.